let's have a look at iron. In iron, when it's corroding, I'm using intentionally spelling it out because the words sound the same. This can be iron or steel. The oxygen diffuses through the oxide layer. This is why iron is not good at resisting corrosion. So we've got iron here. Here we've got oxygen. And in here we've got iron oxide forming. The oxygen dissolves through here, and the reaction's actually taking place at that interface. Iron oxide is a ceramic, which is brittle. The reaction's occurring in underneath, which means it's swelling it out. Then it gets to a point, because it's brittle, it just falls off the surface, exposes fresh iron again, and off it goes, and corrosion happens and happens and happens and happens and doesn't stop. That is what happens when the oxygen diffuses through the layer. If the metal diffuses through the oxide, here's stainless steel, iron, nickel, chromium. We actually get a layer of chromium oxide forming on the surface. Nickel chromium oxide forms on the surface. The nickel and the chromium transfer through the oxide layer. The reaction happens here on the outside. Because the reaction's happening on the outside, the oxide is not getting pushed off the surface. Because it's not getting pushed off the surface, it stays there. So that's an adherent layer of chromium oxide on the surface of a stainless steel, which is why it doesn't rust. So either the metal diffuses through the layer or the oxygen diffuses. That's the background behind a lot of the corrosion theory.